Hello everyone, it's Prodai. I've just kind of jumped into recording today. I haven't recorded for a while, so I might be a bit rusty, as I always am, but especially rusty today because I literally had no plan for what I was going to do today, and I thought, I haven't made a video in a while, there's probably one or two people waiting, why don't I start making one? So let's get started. Like I said, it's generally desirable to have something to store the data that the adder we built will be using. Therefore, we need to get designing some random access memory. That's the kind of memory that we're going to be using to store the data that the ALU will be manipulating. Just repeating myself there, my noob recording techniques kicking in already. Okay, so the layout of bits in a binary computer, a digital computer. What's the layout of bits? We've discussed that already. It literally is binary. You have lots of different columns, or you have a 1's column, you have a 2's column, a 4's column, etc. I've explained that before, and you can make numbers out of these columns. But we want to be able to store numbers. Well, we're going to store them in binary, which means we're going to have something that will save. If you have a 1 in every single column, you'll save where there's a 1 and where there's not a 1. That might be a bit confusing. In fact, not even confusing, I've barely explained it at all. And that's because I'm saving the explanation for Minecraft where I can actually show you the layout of bits. So the bits go into some registers or some memory, it gets saved there, and the bit layout is kind of stored inside that memory cell, like one cell of memory. You can store it in different locations. Anyway, like I said, let's go to Minecraft and it'll be a bit easier to understand then. Okay, so, oh, I forgot to hit record on Minecraft. There's always something wrong, especially today, where, oh my god, I should have come up with a plan for this. Anyway, let's see if I can remember to hit record on Minecraft next time. Okay, I actually remembered. Great, I've remembered to hit record on Minecraft, and, well, yeah, we're in Minecraft. So I've quickly pulled together some basic memory. Let's just take away this. This is unnecessary. But yeah. So the idea behind memory, the idea behind this type of memory, which is memory that you can write to and read from, is that you want to be able to write some numbers to memory. You want to be able to write some information. Let's just change these quickly because it's a little bit confusing. So you want to be able to write some information. Okay. You want to be able to send some information into memory. And once that information is in memory, you can either save it or you can just let it pass through and do nothing. So let's say we want to send in the number 5, which would be these two binary digits. It would be the 1's column and the 4's column. In fact, I'm going to label these. This one can be 1, this one can be 2, this one can be 4, and the last one, which is all the way to the left, that can be 8. So we've labeled our columns now. The 1's column and the 4's column are both lit up, which makes 5. One of my favourite binary numbers. I have no idea why. Just happens to be one of my favourite binary numbers. So right now, if we try and read out of the memory, we get 0. So that's because we haven't saved anything in the memory. If there's nothing saved in memory, what we're going to read out is 0. If I go over here and decide, okay, let's save something to memory then, and then we can read something out. That's what I'll do. I'll save something to memory. I've saved the 5, I'll let it go through, and now you can see here that the 5 is saved in memory. I'm not going to tell you how the memory works. I'm just going to explain the idea behind memory, which is you send in numbers, you can save them, and you can read them out whenever you want. So if I decide I want to read the numbers out, I can hit this lever here, and I get my 5 out, which I've saved in here. In fact, I can even turn off this 5, and because it's saved in memory permanently, then no matter what I do to the inputs, I'll always get, whenever I want to read, the same output. So let's say now I want to store a different number. Let's say I want to store 3. Now if I just send 3 through and then I try to read it, it won't work. I'll still get out 5 because I haven't saved a 3 to memory. So we're getting out 5, but then if I decide to save again, I update the memory cell, then we'll send our 3 through, and our 3 will start to save, and you can even see it here. And if I output it, which I already have, I'll get a 3 out. So if I decide to read from this memory location, because there's a 3 saved in there, if I decide to read from the location, then I'll actually get a 3. So that's memory. We can save whatever number we want, really. I could even save a 0. So like if I read out now, I get the 3 because that's the last thing I saved. But if I update the memory cell, if I save this whatever number I'm putting in, which just happens to be 0, and then I try and read, I won't get anything out because I've already saved the 0. So that's the idea behind memory. You can send in some binary numbers and you can save them. So let's talk about the layout of bits, which I did say I was going to do. Now, as you know, in a digital system or some digital numbers, you have a 1s, 2s, 4s and 8s column. They can keep going. In fact, this is just a 4-bit memory cell. But basically, you turn on the different columns. For example, you turn on the 1s and the 4s, and they sum to make 5. You turn on the 1s and the 2s, 1 and 2 make 3. You turn on the 1s column and the 8s column, 8 and 1, then you get 9, because 1 plus 8 is 9. So you can make different numbers out of binary, but they don't all go in at the same time. So how does this here determine which ones you're going to save and which ones you're not? Well, what it does is you've got this thing called a memory cell. In fact, this might be a bit easier if I built one over here. So the way you build a memory cell in Minecraft is you put kind of like a right angle bit here, but it's double-sided. So you make it like a T, except this side of the T goes one longer than a T usually does. And then you put some redstone here, a block here, torch on the side of this block. You put 2 redstone on top, leaving this one here. You put a repeater. You put a torch on the side, on the back, sorry, and you run this into here. Now this is a memory cell, okay? Your output should be here. Right now we're reading 0 because we have nothing saved. But as soon as we do this, we decide, okay, let's save something. We're still getting a 0 because we haven't saved anything. Let's say we want to save a 1. We update the cell, and that saved a 1. So this is the basis of memory, the idea to save a 1 or a 0, so it can determine whether you're entering a 1 or entering a 0, and it will remember that. It will remember what you entered whenever you want to save it. The only difference between this and here is that you can remember lots of ones at the same time. So I can remember if I have these 3 on, I tell it to remember that, and then when it comes back out, it's remembered that I entered these 3. So basically, memory is just remembering. It's basically just like a computer remembering what numbers you put into it. So if I enter a 1, tell it to remember that 1, it remembers the 1. No matter what I do to the input, it's trying to remember that 1. If I enter a 0, then it will remember the 0. It'll give me out a 0. Even if I change this to a 1, because it's decided to memorize the 0, it will keep giving me out a 0. So there we have it. We have memory at its most basic and a little more complicated. This is probably more useful because we can save numbers and we can decide when we want to read them out. The significance of deciding when we want to read them out is that, let's say we have 3 numbers. We have 5, a 3, and we have a 2. Let's say we want to add the 5 and the 3. Well, we're not going to be wanting to read the 5, the 3, and the 2 because the computer will get confused and it will think, okay, let's send the 2 in along with the 5 and the 3. No, if we want to move some information from one place to another, we might want to read it from the place it's already at, and then we want to save it the place where we want to have it. So we might read the 5, save it to that place, then read the 3 and save it to the same place. However, the 2, we can send that somewhere else. We can read the 2 as well, but what we want to do is we don't want to save it to where the 5 and the 3 are going, otherwise it will add a 2 onto the 5 and 3 and it will mess up our math. Instead, what we might want to do is we might want to send the 2 to, I don't know, an incrementer. So it will increment, basically add 1 to it, and we'll get 3, sorry. Noob recording once again, but luckily we won't be in Minecraft anymore, so I'll see you guys in a minute. So there we go. That's memory, pretty much. So I'd like to discuss a specific type of memory next time. It's called RAM, or random access memory, and I kept mentioning it here, getting confused, saying, okay, I've got a memory cell, and I kept saying, oh, I've got RAM instead. And that probably didn't help with you guys trying to understand this whole thing, because I'm just messing it all up. Anyway, what we did talk about is how to save individual bits of information, like in Minecraft where it could memorize whether we had a 1 sended in there or a 0 sended in there. So whatever we sent, yes, if we sent a 0 or a 1. And we can tell it to memorize the 0 or memorize the 1, or just don't memorize it at all and leave whatever's in there be. I showed you how memory cells are made, so that is lots of these 0s and 1s being remembered at the same time. But I didn't show you how memory is created in real life. The reason is it's quite complicated. And I remember in one video talk about transistors. That's how you do it. If you're interested in that, I probably will make a video on electronics because, you know, electricians, there are plenty of electricians in the world and there are plenty of jobs for electricians. And if you don't know how to do electronics, then you probably won't become an electrician anyway. I diverge. So I haven't shown you this this whole electronic side of things or real life, but I did show you how to make it in Minecraft, which I hope is enough to understand. Anyhow, I hope you enjoyed, but more importantly, I hope you learned.